Pessoal que está ouvindo a gente vai dar mais uns 10 minutos para todo mundo chegar. A gente já começa. Pessoal, eu acabei de ver que entrou uma galera aqui. Vamos só esperar mais uns 5, 10 minutos para o pessoal terminar de entrar. Tem bastante gente que marcou que vinha, mas estamos na metade dos esperados ainda. Vamos só esperar um pouquinho. Beleza, tem bastante gente agora, pessoal. Eu acho que a gente já pode começar o meetup. Vou só pedir uma coisa para vocês. Caso vocês tenham alguma experiência de problemas técnicos ou alguma coisa esteja indo muito mal, vocês podem colocar uma question aqui pelo próprio Hangouts On Air, ou vocês podem me chamar lá no grupo do meetup, manda uma mensagem lá na thread, fala o que está acontecendo, que eu tô de olho lá na página, tá? Bom, dito isso, rapidinho, o William está aqui com a gente. O William trabalha na própria Neo4j e ele vai apresentar um pouquinho das novidades do Neo4j 3.0 para a gente, tá? A gente está fazendo aí mais um experimento com o Meetup Online, então se vocês tiverem qualquer problema, se tiver difícil de entender o inglês, se tiver, sei lá, alguma coisa que vocês precisem de ajuda, eu vou estar por aqui também. Vocês podem me chamar e, sei lá, pedir qualquer ajuda aí no inglês que a gente consegue dar uma mão nisso. Só lembrando também, a gente tem o grupo do Slack do Neo4j Users, então se você é um usuário do Neo4j, se você quer aprender mais, dá uma olhadinha nesse grupo do Slack, é o Neo4j-Users, e também dá uma olhadinha no blog da Neo Technology, sempre está saindo notícias e lançamentos por lá. É uma boa forma aí da gente pegar atualizações da ferramenta, tá? Bom, dito isso, acho que a gente já pode começar. William, I think we can get started. So feel free to show your presentation, and if you need something, just ping me.
Okay, great. Well, thank you, Hanali, for inviting me, and thanks everyone for joining today. Let me just share my screen here. Okay, hopefully y'all can see that okay. Just shout if there's any problems. So today I'm going to be talking about the new Neo4j 3.0 release, which was released last week at Graph Connect Europe in London. There are a ton of really exciting features in here, so I'm really happy to have the chance to talk about this. So this is me. As Hanali said, my name is Will. I work at Neo4j on the developer relations team. So if you have any questions after the meetup, feel free to send me an email. My email's there. I also blog a little bit about Neo4j related things. So check me out online as well if you're interested. So I'm just gonna jump right in to Neo4j 3.0. And what are some of the themes? What are the features? What does this mean for developers? So this will be sort of a high-level overview, and then getting into some of the specifics as a developer, how you can take advantage of some of these new features. So the general theme for 3.0 is a new foundation. So really the entire architecture of the system has been updated at every level, from the core storage engine to the product surface, the way that we interact with Neo4j, to the documentation and configuration options. So all of this has been revamped and updated. So that's why we're calling this the new foundation. And so there are sort of three categories here of updates within this theme, things that we want to enable developers to do. And those are to develop bigger and faster graph applications, to develop applications faster and easier, and to be able to deploy Neo4j anywhere easily. And so really, as a developer, the way I think about these three things are scale and performance, developer productivity, and operability. So let's look at that first one, scale and performance. So for Neo4j and graph databases in general, there's this concept of index-free adjacency. And this is really what makes a graph database is having index-free adjacency. So this means to be able to traverse from one node to any other node that node is connected to without doing an index lookup. And the reason this is important is this property enables us to do local graph traversals in constant time performance. So the size of the data set does not impact the performance profile for a local graph traversal. This is sort of the key thing that makes a graph database a graph database. And so being able to preserve index-free adjacency while being able to offer huge scale is something that Neo4j has always focused on. Neo4j has sort of always been very scalable. If you look at previous versions of Neo4j, so here this article tackling a 1 billion member social network, fast search on a large graph. This was published by a consulting company that was putting together a proof of concept for a client that wanted to develop the architecture for a 1 billion member social network. And so they explored some different options and evaluated the technologies and determined that Neo4j was a good fit here. And so think of the size of the data that's needed for a 1 billion member social network. We're talking about, at a minimum, 1 billion nodes, but then we have, many times that number of relationships. So I think the the data set they were playing with was about 1 billion nodes and something like 7 or 8 billion relationships. And Neo4j went through their tests just fine, from importing data, from writing data, streaming performance was just fine for their tests. So we've really always had this high scalability in terms of the size of the graph, and then also high availability with Neo4j clustering to be able to scale reads. And so we've always had this, but with Neo4j 3.0, we've increased the scalability of Neo4j significantly by what we like to say is upping the limits. So there's always been this explicit limit on the size of the graph that could be stored in Neo4j. And this is a result of the way that the file system is architected. To preserve index-free adjacency, each node has to have a direct pointer to every other node. And so we have to allocate the space in the file system for this. So with Neo4j 3.0, we've removed those limits, effectively allowing for storing a graph of any size in Neo4j. So that's really exciting. We've done this using a technique called dynamic pointer compression. So this applies to nodes, relationships, and properties. And there's a smart algorithm there that is able to ensure that we're taking up less space on disk. So not only are we able to store giant graphs with no bounds, as we're using less space on disk for smaller graphs as well. So that's the main things in scale and performance and the updates of 3.0. We'll see a few more later on, but that's the big highlight. So let's talk about developer productivity now. So just giving a brief overview of the product surface, the developer surface for Neo4j, so how developers interact with Neo4j. Neo4j started as an embedded Java graph database. So we had this embedded Java API that you would use, and that was the only method to interact with Neo4j when Neo4j was first created. Then about 6 years ago, we created a REST API, so you could make REST HTTP requests to Neo4j and get your response back in JSON, work with the graph that way. Then in 2014, with Neo4j 2.0, we introduced Cypher, which is the query language for graphs, which really changed the way that we interact with Neo4j quite a bit. Everything was done using Cypher, but those Cypher requests went through HTTP to Neo4j. So now with Neo4j 3.0 in 2016, we've introduced Bolt, which is a new binary protocol for Neo4j. So this is replacing HTTP as the mechanism for sending those Cypher queries. And along with that, we've introduced several official language drivers for JavaScript, Python, .NET, and Java. And so now, rather than using HTTP directly or using one of the many community drivers that were developed by the community, we have these officially supported language drivers that implement the Bolt protocol, so you can interact with Neo4j using Cypher that way. As I mentioned, Bolt is this compressed binary protocol it's replacing HTTP for interacting with Neo4j. The reason for this are a few. One is that it gets rid of the overhead of HTTP, so that HTTP handshake. The other is that we're able to compress the data that we send over the wire much more efficiently using Bolt. And again, as I mentioned, we've introduced 4 official language drivers in JavaScript, Java, Python, and .NET. And the goal for these, first of all, that they implement the Bolt protocol. The other benefit we get with Bolt is this unified type system. So now we know when we get results back from Cypher, we know that they adhere to this unified type system, and that's going to be the same across all of the language drivers, and that maps to something idiomatic in the language that we're using. Now, these are fairly low-level drivers, so these can be sort of built on top of to integrate with other frameworks. So, for example, there's a Spring Data Neo4j integration that uses the Java Bolt driver, as well as the object to graph mapper. So there are a few different layers there that you can build on top of the Bolt drivers. Another thing that's really beneficial with the official language drivers is a sort of unified system across the drivers. So every driver has a concept of a session, which is your connection to Neo4j, has a concept of result, which is your results from a Cypher query. So using these drivers, while they're idiomatic to their language, using them across different languages and talking to other Neo4j developers who may be using a different language, but you're still using the same concept. So here's what this looks like in JavaScript. We instantiate the driver, we specify we want to use the Bolt protocol on a machine running on localhost. We create a session, which is our connection to Neo4j, and then we run some Cypher query and we get back a result. So this looks very similar in Python, in Java, and in C#. Another piece of developer productivity that I think is really interesting is Java stored procedures. So stored procedures are user-defined code that's written in Java or any JVM language. It's deployed to the server and then callable from Cypher. So we write some Java, package that up as a jar, deploy that to the Neo4j server, and then we can use Cypher to call our stored procedures. And this is really cool for things like connecting to other databases. So there's a JDBC stored procedure. There is a metagraph stored procedure, so we can inspect the graph schema that we have and get some visual representation of that. So stored procedures are really interesting, and we'll explore these in a bit later on. So in terms of developer productivity, these are the sort of the key updates in Neo4j 3.0 is Bolt, the new binary protocol, the official language drivers, and Java stored procedures. In addition to that, we've launched a new product as part of Neo4j Browser called Neo4j Browser Sync. So you can think of this as a cloud service for Neo4j Browser. This is something that you log into using your GitHub, Google account, or Twitter account. And this allows you to save stored Cypher queries or style sheets for the graph to the cloud, and then you can then access those from other computers, other servers using Neo4j. So this is just another thing to enable developer productivity. You don't need to be copying these back and forth, saving these in a text file or something, so you don't lose your favorite Cypher queries. These are now persisted in the cloud for you to be able to access later. Okay, so that was developer productivity. Let's just take sort of a high-level view at some of the operability changes in Neo4j 3.0. And really, the changes here include updates to the Neo4j Docker image. So the official Neo4j Docker image came about with version 2.3. but we've made lots of updates to the Docker image to simplify the way you can specify configurations and logging. And as part of that, we've reorganized the file structure for Neo4j itself. So there's now one unified configuration file. There's now one unified log file. And really the goal here was to align these things with what we would expect in these modern deployment scenarios around hosting in the cloud, containerization, and things like this. So when we talk about 3.0 and the new architecture foundation, the key takeaways here are upping the limits. So a new storage engine with no limits on the size of the graph that we can store. Bolt, the new binary protocol for interacting with Neo4j using Cypher. Official language drivers that support Bolt. We haven't talked about this yet, but we'll get into this a bit later. Some Cypher performance improvements, and then file config and log changes to enable deployments. Great, so that's great. So that was let's dive into some specifics here. So if we look at the release notes, let's go ahead and do this here. If you look at the release notes for 3.0, you can see there's a ton of stuff in here. Actually, if we look at the change log, we can see really a ton of things going on here. So I don't have time to talk about all these, but I would encourage you to sort of read through this so you can see a lot of the big changes that we've made. So one thing to note here is that going forward, all 3.0 versions of Neo4j require Java 8. So that's certainly something to be aware of. Another thing that I want to mention is the documentation. So previously, the documentation consisted almost exclusively of what was called the Neo4j manual. And while that was great, it got to be this very long, I think it had 30-some chapters and a lot of content. So what we've done is split up the documentation into a few different pieces. So we now have the Neo4j developers manual. And so this is documentation for anyone developing a application with Neo4j. And we have specific versions for all of the different language drivers with examples in that language. And then we have the Neo4j operations manual. And the operations manual is more for folks that are deploying and maintaining Neo4j. So this includes things like deployment, security, backup, monitoring, performance tuning, looking at the config files that you might be editing, things like that. So if you're looking for the old Neo4j manual, it's been broken up into these two pieces. And then this is also the page where you can find language-specific documentation. So documentation exclusively for the JavaScript driver. So how do I install that using npm? How do I get started? While we're talking about the JavaScript driver, I just want to mention one thing that I think is really interesting with the JavaScript driver is that there is both a Node version, so using JavaScript on the server, but we also have a browser version of the Neo4j JavaScript driver that uses WebSockets to connect to Neo4j. So I think that's very cool. Okay, so that's the documentation. Let's take a deeper look at these stored procedures. So again, these stored procedures, these are user-defined code written in Java that is deployed to the database that we then call using Cypher. And there are a bunch of these built in. So we can say call db.labels, and this inspects the database and returns all of the labels that we have in the database. Things like constraints. We can see all of the procedures that we've installed. Here's an example. If we call db.labels, and we'll see, okay, these are the labels we have in the database. So that's helpful. But we can also define our own procedures. So not just the ones that are shipped with the database, we can also build our own and deploy those. And if you're interested in building your own, there is this template project on GitHub, the Neo4j procedure template. And basically what this is an example of building a full text index. So it's very verbosely commented here, so you can see exactly what's going on. There are a few annotations that you need to use. Basically, a procedure returns a stream, and in this case, we're searching for some index hit on something that we've already indexed using a full text index. Here we're creating and adding node to the index. So if you're looking at building your own procedure, that template is a good way to get started. We also have what we're calling APOC, or awesome procedures for Neo4j. So this is a library of, the last time I looked, there were over 100. Not sure how many we have right now. These were started by Michael Hunger. I'm sure many of you know Michael Hunger from the Neo4j community, and also some other folks that have added a few things. And there's a ton of stuff in here. So things for dealing with what used to be called the legacy indexes, looking at the meta graph, so inspecting the graph schema that you have, getting write locks, and then there's a ton of stuff for loading data. So loading from JSON, loading from a relational database, loading data from the web, really lots of cool stuff in here. So if there's something that you're trying to do in Cypher that you can't quite figure it out how to do that in Cypher, or if you need to make some external internet request, something like that, procedure is the way to go. So be sure to look at the APOC procedures to see if someone's already built that for you. Here's an example of calling the meta graph. So with the movie data set, so the movie data set has person nodes and movie nodes, and a person can have either acted in the movie or directed the movie. So if we run apoc.meta.graph, we get this nice visual representation of what our data model looks like. Let's look at a specific example of importing data into Neo4j from a relational database. So this is something that I hear pretty frequently, is how do I get my data from SQL Server into Neo4j? So let's hop into Neo4j. So this is Neo4j 3.0 instance here. I have nothing in the database, so we can do match a turn count a just to verify that there's nothing in here, and we get 0. And so somewhere here I have MySQL. Somewhere there. And I have MySQL running with the Northwind data set. So let's take a look at Northwind. So Northwind, so here's the ER diagram for Northwind. This is the canonical relational database example. So we have tables about orders and customers, the products that the customers have ordered, the employees that fulfilled them, and whatnot. So if you've ever done any sort of work with SQL Server, MySQL, or learned about in school, you've probably seen Northwind, or at least something that looks pretty similar. For now, let's focus on these 4 tables here. So orders, products, customers, and then this order details join table. So if we were to import these 4 tables into Neo4j as a graph, it might look something like this. So a customer placed an order. That order contains a product. Okay, that's great. Let's see how we could import that into Neo4j using some of the new Java stored procedures. So I've installed APOC. So it's worth mentioning how I did that. So here I have Neo4j running. If we go to the plugins directory, you can see that I have a few jars here. So I downloaded APOC from GitHub, and then when I built it, I just copy this jar into the plugins directory. Because I'm going to be connecting to MySQL, I also need to install the MySQL connector jar that's available to download online. So copy these jars into the plugins directory, and then just restart Neo4j, and these will load. So I don't need to update any configuration other than that. Okay, so the first thing we're going to do is register that we want to use the MySQL JDBC driver. So this is the Cypher command. So we say Cypher call apoc.load driver and specify the package that we want to load. So this is what the syntax looks like for calling a procedure. So we run that. We don't get any results, so no error. That seems to have worked fine. So the first thing we want to do is insert our product nodes. So here we're going to say call apoc.load JDBC, and we're going to specify the connection string. So running locally, we're interested in the Northwind database. I haven't specified a password. If we had a password, we specify that here. And then this piece, we can either specify a table or a SQL statement. If we specify a table, we'll essentially just select star from products. And then we're going to be piping those through to the rest of the query with this alias row. And we're saying, okay, create products with a product ID from the row that we're getting for the product, and then set some of the other properties. So we run that. Okay, we've added 77 products. We do almost exactly the same thing now with orders, creating 830 order nodes. Now we can add some relationships. So for this order details join table, we want to know, okay, where's the product, where's the order, and then we'll create this relationship that says this order contains this product. So we'll run that. That takes a couple seconds because I did not create any indexes on our IDs. Would have been much faster if I had. Okay, and then just to finish this out here, customers. So again, customer table, very similar to the previous example. And then for every order, we need to know what customer placed the order and create this placed relationship. So we run that. Okay, so let's see if we did this correctly. So here, 25 random products, we can double click here to expand, and we can say, okay, cool, here are all of the orders that contain this product. So for this queen order, let's see, what other products does that contain? Okay, so we can traverse out and see the customer that placed that order, expand out and see all of the other orders that this customer placed. One thing that's new in the browser in Neo4j 3.0 is if we go to full screen mode here, we have browser zoom. So this is something that I think a lot of users found frustrating previously, was visualizing large graphs in the Neo4j browser. We didn't have a very good zoom mechanism. So now that's been updated in the 3.0 version of the browser. So that's pretty exciting. Okay, so that's fine. We've imported Neo4j, or we've imported Northwind into Neo4j. What are some graphy things we can do with that? Well, one thing we can do is a simple collaborative filtering product recommendation query. So we've all seen recommendations before, and I'm sure some of you have even written recommendation algorithms using Neo4j. This is things like, okay, if I go to Amazon and buy some shoes, it's going to recommend products to me that I might be interested in because other people that bought the shoes that I bought these other products. So maybe things like running shorts, or if they're tennis shoes, maybe a tennis racket or something like that. So that's this idea of collaborative filtering. So we can express this in Cypher. So let's match on some customer. So Roland Mindell, just picked him sort of at random out of the Northwind data set. Let's look at orders that he's placed, and let's look at products that are in these orders. Then let's look at other orders that contain this product and the customers who place those orders. So what customers are ordering the same things as Roland. And then for these other customers, let's look at other orders that they've placed and what products are contained in those orders. So we're essentially saying, find everything that Roland bought, who's buying similar things as Roland, and for those people buying similar things, let's find other products that those people are buying. And then we're going to return those products as recommendations for things Roland might be interested in buying, and we'll use some weighting to order those. So here we're counting all of the paths that we find for a specific product. So if we found 10 customers that have placed orders for some product, we'll weight that higher than one where we just have one customer who has something in common with Roland. So if we run this, we can see these are the products that Roland might be interested in. So the first one is Gorgonzola Tellino. I don't know what that is. Maybe sounds like some sort of cheese pasta or something like that. And we can see all of these other products. So what we did there, we imported data from MySQL into a graph, and then really quickly we're able to run interesting graph queries on that, in this case, product recommendations. So I'm really excited about stored procedures. I think this is really going to change the way that we build integrations with Neo4j going forward. So really excited for that. Let's talk about Cypher. So there are some performance updates to Cypher in 3.0. The biggest one is cost-based optimizer for writes. So we introduced a cost-based optimizer for read queries in Neo4j 2.2. And basically what this did is when a Cypher query is being converted into an execution plan, we have a couple of choices of the operations to that should be converted into. And the cost-based optimizer is able to take into account the statistics of the database as it currently exists. So things like how many nodes of this label do I have, and do I have an index on these things? It's able to take that into account and optimize the query plan based on the current state of the database. And so we've been able to do that for read queries for the last couple of versions of Neo4j, but we were not able to do that for writes. So now with Neo4j 3.0, we're able to take advantage of the cost-based optimizer for writes. Neo4j is also updated to Lucene 5, so now we can populate indexes much more quickly. We talked about Bolt. So Bolt will now be the default way of interacting with Neo4j using Cypher. This will help performance as we don't have to deal with the overhead of HTTP, and we're also able to compress data that we're sending over the wire. There have been other important improvements with string-based functions. Ends with and contains now use an index. There's also starts with, which had always used an index. So if we're doing these string comparisons, these will be much more performant now. We're also able to use global aggregation queries using essentially a lookup. So if we want to count all of the nodes in the database, we can just do a statistics lookup. We don't need to actually touch all those things and count them. So this will be a big boost for these sort of global aggregation queries that had to look at statistics for everything in the database. Here's just an example to give you a better idea of the cost planner. So previously with the rule planner, if we wanted to match on every product category and then look where the product category ID and the category ID matched, and then creates this contains relationship. If we wanted to do that previously, we ended up creating this Cartesian product and then doing our create statement. So to do this operation previously using the rule planner, this took 7 seconds and 3 million database hits. Now, using the cost planner, we're able to do an index seek. So this is now much more efficient. We're only doing 50,000 database hits, and it takes less than half the time to do this. So the main area where you're going to see the biggest improvement for these kinds of write statements is in load CSV, where you're loading data from CSV files and then doing some write statements. So previously, all of load CSV that we're doing writes we're using just the rule planner. Now taking advantage of the cost planner, those should be much more performant. So that's really exciting for importing data. Another change in Cypher is that predicates are now pulled into the shortest path function. So this is cool. So if we wanted to say, let's find 2 nodes in the database, Berlin and Dresden, and I want to find the shortest path between Berlin and Dresden, we could do that with the shortest paths function. But we weren't able to specify predicates. So things like, okay, find me the shortest path from Berlin to Dresden, where none of the roads are closed and the speed limit is not below 30 because I don't want to drive very slowly. And I also want to reduce to aggregate on the total distance that I'm traveling, and I want to specify that that needs to be below some threshold. So now all of these predicates are pulled into shortest path. So we're able to take all of these predicates into consideration when doing the shortest path. So for these type of routing queries, this is going to increase performance a ton, because now we don't need to find all the shortest paths and then compare all of these, we're able to pull these in to the shortest paths function. So really cool there. There are also some new spatial functions in Cypher, specifically a distance and point function. So if we have a node that stores a longitude property and a latitude property, we can coerce that into a point type in Cypher, and we can then calculate the distance between 2 points. So here again, using Berlin and Dresden, we can compute the distance between those two. So again, this is going to be very useful for things like routing. I want to talk just a little bit about upgrading to Neo4j 3.0. So as I mentioned previously, Neo4j 3.0 does now require Java 8. It's also worth noting there's a new store format for Neo4j 3.0. So if you want to upgrade a version of the data store from Neo4j 2.3 or older, you can do that. But note that that store will need to be rebuilt. So there's a flag in the configuration to enable that configuration on restart. Also, as I mentioned, the configuration structure has been redone in 3.0. Let's take just a little look at that. So in the conf file, so previously there were a couple of Neo4j configuration files. We had Neo4j properties, we had Neo4j server. It's all been unified into neo4j.conf. So if we look at this file, there are lots of different options in here now. So one thing we can do, we can specify the name of the database to mount. So we can actually store multiple file stores, multiple versions of different databases for Neo4j, and specify in this configuration file which one we want to mount at any given time. We can also specify different directories for our data or for our plugins. We can also specify for load CSV where we want to load those files from. So if we want to use the import directory, if we want to use something else. But here, this is what we need to enable to upgrade from a previous store. So if we're upgrading from version 2.3, we copy over this graph.db folder, put that in the data directory. So things we've done previously if we've upgraded from previous versions, but now be sure to specify allow format migration equals true to be able to upgrade the file store. We can also configure the size of the page cache, so these sort of memory allocations for Neo4j. Also have some specifications for the new Bolt protocol and so on. I won't go through the rest of those. There is a migration tool, so something that can help you map your existing configuration option in 2.3. It will generate what the 3.0 version of that configuration should be. And there's more information on that tool in this in the upgrade section of the Neo4j manual. Yeah, and as I mentioned, the manual is the section to look at for more information about upgrading. So cool. So we talked about all these awesome features in Neo4j 3.0. Neo4j 3.0 is available right now. You can go to neo4j.com/download to download this right now and play around with it. It's also available on Docker as a Debian package. So lots of different ways to get started with Neo4j. Great. Well, that is all the material that I have prepared at the moment. I don't know if we have time for any questions or what the plan is there, but Hanali, if you want to take some questions from the audience, if that works for your format, please do.
Pessoal, vocês têm alguma pergunta? No canto esquerdo do Hangouts on Air, tem uma seção de questions and answers. Aí vocês podem digitar as perguntas lá. William, we have a couple questions here. Can you see the questions and answer session, or I can read for you?
Oh, I'm sorry. Is there a chat?
No, you don't have access to it. So the first question is from Rafael. He's asking is Neo4j compatible with GraphQL or easy to implement?
Yeah, that's a great question. Yeah, so GraphQL is sort of this. I don't know what to call GraphQL because it's really a bit more than a graph query language. It's sort of a serialization protocol. Yeah, so the question is Neo4j compatible with GraphQL? And the answer is not at the moment. Some folks internally have been playing around with some Java procedures for converting GraphQL to Cypher and converting Cypher results to GraphQL for sending those back. It's not quite ready for prime time, but it's definitely something that we have some folks working on. So certainly there'll be some more information once that becomes available.
Great. So Rafael, are you still there? I don't know if he's still here, but he said he had another question because his context was they're migrating their apps from REST to GraphQL. Then GraphQL supports iOS, Android, and some backend admin tools. And he had a couple questions based on that. So, Rafael, if you are still there, feel free to give us another question.
Yeah. I mean, GraphQL is certainly something that we want to be able to support. So yeah, I'd definitely love to chat with him more about that. Feel free to message me offline. We can definitely dive into that.
Great. So let's see if we get another one. Pessoal, se vocês tiverem mais alguma pergunta para quem ainda está aqui, é só colocar na seção de questions e answers, tá? Aí a gente vai falando. Não, mais nenhuma pergunta? Vamos lá, última chance. Só lembrando que o vídeo da apresentação provavelmente vai estar disponível no YouTube. Vou só perguntar para o William se tem problema da gente publicar. E só lembrando que a gente tem o Slack, o Neo4j Users. Aí, se vocês não tiveram a oportunidade de perguntar aqui, pode perguntar depois lá no Slack. William, I think we are okay. I think no one else has questions by now. So do you mind if we publish this session into YouTube?
Yeah, that's fine. Absolutely.
Cool. So then I think some people could not attend, so they can check it later. So thank you so much, William, and we are very pleased to have you presenting these new features from Neo4j 3.0. So thank you so much for helping us. Pessoal, muito obrigada aí por aparecer na sessão. O feedback é muito mais que bem-vindo. Se tiver alguma coisa que vocês tiveram dúvida, é só perguntar. Se vocês acharam que essa modalidade de a gente ter um meetup que eventualmente é online foi bacana para o pessoal que não mora em São Paulo poder aparecer e aprender um pouquinho das novidades, dá um feedback para a gente, é um feedback importante da gente ter. Se vocês não gostaram, só falar. Se vocês têm alguma sugestão de melhoria, a gente a gente aceita muito bem, e também elogios são sempre bem-vindos. So, thank you so much, William, and pessoal, valeu, e até a próxima.
Great, thank you for having me. This was fun. Cheers.
Thanks, bye-bye.